We know how to represent the structure of a molecule using a Lewis structure. Now we can use valence shell electron pair repulsion theory to determine the shape. From the shape, we can determine the polarity of a molecule, and from polarity, we can determine the intermolecular forces. Intermolecular forces helps explain properties such as solubility and boiling point. So let's do an example of how structure determines shape, which determines properties such as polarity. Water is called the universal solvent. Stop the video and answer these questions about water. Before we review the answers, let's talk about shape. A central atom is an atom bonded to two or more atoms. Electron pairs that surround the central atom are either bonding pairs or lone pairs. In valence shell electron pair repulsion theory, the electron pairs want to be as far away from each other as possible. The shape or geometry at a central atom depends on the number of electron pairs around the central atom. Two electron pairs are on opposite sides of the central atom. That will give a linear shape. Three electron pairs will arrange themselves at the corners of a triangle. That's a trigonoplanar shape. With four electron pairs, each electron pair is at the corner of the tetrahedron. That gives a tetrahedral shape. The number of electron pairs equals the number of bonding pairs plus the number of lone pairs. This table relates the number of bonding pairs and lone pairs to the shape at a central atom. Keep this table handy. In VSEPR theory, treat a double bond or triple bond the same as a single bond. Let's do an example with ethylene. At each carbon, there's two single bonds and one double bond. Treat the double bond like a single bond. A double bond has two bonding pairs treated as having one bonding pair. So each carbon has three bonding pairs, therefore the shape is trigonoplanar. Now it's your turn. Stop the video, draw the Lewis structure of acetone, and determine the shape at each carbon. And the answer is, these two carbons have four single bonds, so four bonding pairs, and zero lone pairs means tetrahedral. The middle carbon has two single bonds and a double bond. Treat the double bond like a single bond, so the carbon has three bonding pairs, so the shape is trigonoplanar. Shape and bond polarity determines the overall polarity of a molecule. Electronegativity is the ability of an atom in a bond to attract electrons toward itself. This property determines bond polarity. When two of the same atoms bond together, the ability of each atom to attract electrons toward itself is the same. This means the bonding pair of electrons are shared equally between the atoms. This equal sharing is called a nonpolar bond. When two different atoms are bonded together, there's unequal sharing of the bonding pair of electrons. This gives a polar bond. So there's a tug of war for the bonding pair of electrons between two atoms. The more electronegative atom is going to win that tug of war. The chlorine-chlorine bond is a nonpolar bond. Equal sharing of electrons and a uniform electron density around each chlorine. The HCl bond is a polar bond. Chlorine is more electronegative than hydrogen, so chlorine wins the tug of war for electrons. More electrons around chlorine, so chlorine has the minus pole, H has the plus pole. Here are the answers for water. Let's discuss why water is polar. Each OH bond is a polar bond. Oxygen is more electronegative, so let's point an arrow toward the oxygen. Water is bent, so imagine each H pushing on the O at that bent angle. Is the O going to move? If yes, water is polar. If no, it's nonpolar. The O moves, so water is polar. Water is polar, HCl is polar, so HCl dissolves in water to form hydrochloric acid. This is an example of the like dissolves like rule. You probably have some rubbing alcohol at home. It's used as a solvent and disinfectant. Stop the video and determine which structure is rubbing alcohol. And the answer is, stop the video, go through these steps so we can answer this question. And the answers are, rubbing alcohol is polar. Oxygen has a bent shape, so imagine the H pushing on the O, the C pushing on the O from the other side. The O is going to move. Polarity is related to dipole moment. A molecule with a dipole moment equals 0 is nonpolar. A molecule with a non-zero dipole moment is going to be polar. Let's practice. Stop the video and answer these questions. And the answers are, here's the methane combustion reaction, and here are the Lewis structures. Here are the shapes. And polarity. From our like dissolves like rule, none of these compounds are soluble in water. Salt is an ionic compound. The sodium cation and chloride anion make sodium chloride polar. So polar salt dissolves in polar water. Let's look at ammonia. Nitrogen is more electronegative than hydrogen, so each NH bond is polar. Imagine each H pushing on the N. Is the N going to move? The answer is yes. So polar ammonia dissolves in polar water. And here's ethanol. CH4 is nonpolar, so this part of ethanol is nonpolar. But oxygen has a bent shape, so imagine the H pushing on the O and the C pushing on the O from the other side. Is the O going to move? Yes, so ethanol is polar. So polar ethanol is soluble in polar water.